Welcome. Here I show my problem 8 model paper 8 solutions, brief solution through this video. My structured question paper 8. I hope you complete before me. You are waiting for my solutions. So see the first question. The ring, circular ring, the two small pebbles threaded to that at a lower point or wherever you can show that thing. The diagram is given there on a horizontal table is kept. So the particle one called capital A, other one is B, the mass is small m and capital M. A come with velocity u and collide with the B. I mentioned after the collision, the velocities are respectively v1 and v2. So problem is find the velocity after the collision speeds. First we complete that. This ordinary impact problem, but along a circular ring. So we use that momentum principle and the Newton's residue. They say the E is the coefficient. Apply and find the v1, v2. Therefore, the first part, apply principle of momentum, right? Apply momentum principle. Apply the momentum principle in this direction. Final momentum equal to initial momentum. So small m, when mass, I mentioned the velocity v1 plus the other mass capital M. I say the speed is v2 is the final momentum equal to initially what? Small m and the u, right? Your first equation. Next apply by Newton's restitution law. By Newton's restitution law, right? By Newton's restitution law says velocity of the separation equal to E into coefficient into approaching velocity, right? So therefore the v2 the higher than the relative velocity is both v2 bigger than v1. So v2 minus v1 equal E into approach is u, right? That's all here. The applied maths work, collision problem, that's all. Now solve and find the velocities v1 and v2. Ordinary this simultaneous equation type. If I remove the v1, how that? First equation multiplied by here mv1, here mv2. First equation add with the second equation multiplied by small m, right? So here mv1 minus mv1 cancel. So capital M plus here small mv2. So small m into v2 equal, the other side take u out, m plus here this also multiplied by m, mu. You can take the m also out, right? Check will do that. Then 1 plus what is that? EU into small m. This process find the v2 answer. So that gives you therefore v2 is 1 plus, take u also out, 1 plus E mu over what? Capital M plus small m, right? This is the speed of the velocity of one particle after the collision. That means I mentioned this for B, velocity of the pebble B after the impact. Now how to find a v1? Remove the v2, the same method or substitute. First equation, subtract the second equation by capital letter M. Okay. So here mv2 minus mv2 cancel. This becomes a small m minus capital M. If you subtract, this becomes positive. You remove the v2 remove here, subtract plus into v1 equal first equation mu, m times u, This is capital M, EU, subtract, take the, some like here, let's say take out, then becomes here 1 minus capital MU, right here small m, U minus capital MEU. So therefore the answer answer small m minus capital ME into U, right? Check, will you? Therefore the V1 answer, the first velocity, that means the pebble A, right? I mentioned V1 for pebble A, its velocity after collision is this. I hope you completed this, check these answers. So now what they ask, after the collision, find the speeds. Okay, if A moved a distance of pi A by 2, after the first collision, A moved, what do you mean, pi A by 2, quarter circumference part, pi A by 2, okay, pi A by 2 means complete circle, 2 pi A, half circle is pi A by 2 means somewhere here. If I assume the first collision here, so A moved here, then B moved again, collide with the A. So first occasion A collide with B, but second occasion B collide with the A, right? Because both moving same direction. So in this case both are moving after the collision, both are moving. Therefore we have to check with the relative motion idea. If both moving, we think the relative velocity component, that idea, relative motion idea, right? So in this case we find that velocity of B relative to A, velocity of B relative to A, because A moves somewhere here, B come and collide with the A. On that case we see how the A, I am A, B come and collide hit with me. So therefore according to me, the relative velocity, how the B, you will find that things. So if I show by diagram form, so I think somewhere here, right? Somewhere here the A moved, actual center is O. So from here to here they said pi A by 2 distance, that's A moved, right? Okay, so here think about the relative velocity component, relative motion. Therefore I want to find that velocity for second impact, right? For second impact, you can write for your revision, consider relative motion, right? Why the relative motion? Both are moving, right? Therefore in this case I want to find the velocity of what B relative to A, because B comes and collide with the A, right? So if you learn properly the velocity, relative velocity, the chapter separately, you know what you mean. Velocity of B relative to A mean A is rest, B comes and move with that. So you know the two speeds. Therefore A is V1, B V2. Think about A is rest, so B moves a complete circle and collide with that, right? So velocity is what? V2 minus V1, okay? V1 is bigger, therefore relative case. So after first impact, A not moving, A is rest. That's the meaning of the relative velocity component, right? So but you know somewhere V2 minus V1 is EU, right? Later you need this part, EU is the velocity of B relative to A. So they said A moved pi A by 2. A moved a distance pi, as I mentioned somewhere here, pi A by 2 distance A moved, right? Now here the time factor. I said time is small t for the both collision, second collision after the first collision, right? Let the time taken for second collision, right? For second collision or impact, I say t. I say time is t. So we can find the time factor now. So what is time equal or distance equal velocity into time along this circumference chart. Therefore, for the first occasion, A moved, find the time taken for A. Find the time taken for A. Therefore, time taken for, I say A. First write the time taken for A. What is time? Let's say A moved pi A by 2 distance. So time t equal distance pi A over 2, okay, into velocity. A is v1, right? A velocity is v1. Next, time taken for B. Find B. Time taken for B. The same time. This time is independent but common constant part for the both occasion, right? Time. So how the B move, that is relative velocity, that means A is rest, B moving and collide after the first impact, that means A moved a complete circle, that is 2 pi A, right? 2 pi A, and its velocity relative to that A, v2 minus v1, or otherwise, you know, 2 pi A over what? Over EU. Therefore, connect the both, you can go to the third answer. Connect these two equations, connect these two answers. I show here, therefore, pi A over 2v1 equal to pi A over EU. So both sides pi cancel, A cancel. So EU equal 4v1, right? So we got the answer v1. Here v1 is small m minus this. So now cross multiple, subject the E answer. Problem is show the E is given there. So by cross multiple, take the common E, cross multiple. So E EU into small m plus capital M. Here 4 into small m minus capital M E into U. So here take this O and take the U out, EU out. Here got small m plus, is it what, 4 capital M, EU out. The answer here 4 small m, and here multiple is completely EU, small m plus 4m. The answer there 5 is available. Yes, 5 is completely 5 capital M. Check value. Here 1 capital M, this side 4, therefore small m 5, that side 4, and therefore the answer U equal, E equal, divide 4 small m E in U into small m plus 5 capital M is the answer that's provided there. So U cancel, U also cancel, right? Check value, U also cancel here. The E answer is this, right? Check value. So I hope you complete this simple problem. The main part, second issue is using relative velocity component idea. See, second question. Second problem, that is VT graph. So some papers, the past exam structured also, they provided the velocity time curve also in the essay as a big question. So here from a point O on the ground, the ball is projected vertically upwards. Those are newcomers, you can see this channel, the paper is available, right? velocity u, when that ball is reaches maximum height, another ball is projected from a vertically upward velocity for you. So if I describe that, always the VT graph, better you describe before drawing the graph. So you mark something to the ground level. Here, if I say the A is velocity projecting upward, that is, they say U, right? Time is 0. Time is 0, it's moving upward, vertically upward. So it's the path of that projected is first one. Later, when the later is projected, when A1, first occasion is at the highest point. Therefore here speed is 0, right? Speed is 0, the final velocity is 0 on that occasion. Second is projected the same point, from the same point. If I say B, the speed is given 4u over 3, right? If the initial speed is 4u over 3. Then what happens, somewhere these both collide. When it's collide, the above first one comes down, it's moving up. Okay, this is B, here A. This is the system, that initial diagram. A is projected with the velocity u. Later, when the first one goes up highest point, second is projected. You can work this question using the what we call vertically motion, under gravity motion equations. You can answer this full solution. But here the problem is using the velocity time graph, right? Using the velocity time graph. So if I mention that one, if I draw here, I show here the VT graph for the both time, velocity. So how the first one projecting with the velocity u. So what happened under gravity? This is a retardation motion, right? Because acceleration, upward retardation, down that under gravity. Therefore, the graph, okay, is the point where the first particle reaches its maximum height, right? So when it's taken maximum height, the second particle is projected. How the second particle, that is the 4u over 3, therefore that velocity is higher than the previous one, right? That also, that similar under gravity part. So if I mark somewhere here, its speed 4u over 3, 4u over 3, that is moving like that. Both parallel, because the tan theta, you know these things, because both are same acceleration, or here both same retardation, upward motion. This is the complete first part answer. Draw the diagram for the both of this motion. Draw the VT graphs for the both motion, the same plan, same diagram, right? Also we can find something, what the time taken first particle reach its highest point. So if I mark time is t after the first is projected, right? So what the time t ordinary method, you know, VT graph 2 theory is available. One is tan theta, or the gradient or the slope gives you acceleration or retardation. Other one is area under the curve is displacement or distance. So if I mark here theta, so what is that? We are tan theta equal u over t, that is g, okay? Therefore t equal u over g, time taken to the first particle to reach its maximum height, or when the second particle projected after such time, after that time second particle is projected, right? Okay, this is the first occasion VT graph. Now they ask, by drawing another VT graph, by drawing another velocity time graph for the motion of the first ball relative to the second. First, I mentioned first one is A, second is B. So now they ask, draw the, if I show the axis. Now the axis are how? Time is same, time is constant. Here what the velocity of A relative to B, right? Relative to B you will draw. That means B is at rest. B is at rest, observing the A, how its motion, how its path. So we'll complete that diagram. Therefore, initially this is projected. Initially your A is projected. There's no B. So up to this time interval, that is same as the previous type graph. That is same as the previous graph, right? If I show that, here this is the graph. You know time here, U over G is the graph for the first T time, or U over G duration, because there's no B. After that only we have to think about the B. So relative motion cases, so time is 0, and up to time U over G is the graph part, right? We'll see after that what happened. After that how? So at T equal U over G, at T equal U over G, what is the velocity of A relative to E? You have to find this component, then only is easily explained the shape of the graph, right? At time equal U over G, what the speed of the first particle according to the earth, difference to the earth, that is 0, okay? Because the highest point, that is 0, right? The same time, velocity of the B related to earth are projected by upwards 4U over 3, right? 4U over 3. Therefore, we can find the relative component velocity of A related to B. Therefore, velocity of A related to B is what? Velocity of A related to earth plus velocity of E, B, okay? Velocity equation, relative components. So what that, therefore, velocity of the A related to earth is 0 plus, this is how EB, upwards B comma E, so EB downward, right? Downwards 4U over 3. Okay, 4U over 3 is the answer for what? At time equal T U over G, when velocity of A related to B, right? This is the velocity of after time U over G, otherwise when the second particle projected, okay? Now we see the acceleration also. To draw the VT graph, you need the velocity, you need the acceleration also. Then only know the shape. Is it acute angle or obtuse angle or parallel line, like that. Now similar fashion we find the acceleration, right? After projecting the first occasion, I say A for acceleration. Acceleration of A related to Earth. Everything at this time, right? So velocity of the acceleration of A related to Earth at the highest point under gravity, downward G. Okay, downward G. What the acceleration of B related to Earth at the, after this time, you see this diagram, that also same part comes downwards G. It is G downwards G. Okay, very important part I am showing, not only for this, think about the future problem, how to implement these ideas, right? Therefore, acceleration, I need to what? A related to B can be shown acceleration A comma E plus acceleration EB, okay, so what is that? AE downward G plus EB, therefore upward G, so no doubt answer is 0. What do you mean acceleration 0? Uniform velocity, constant velocity, okay. Therefore initially what the speed 4u over 3, same velocity maintaining on that occasion, but you know it's downward answer 4u over 3. Therefore the both collide after second projection. So in this case you draw graph how. Somewhere if I mark this is the 4u over 3, 4u over 3, it becomes uniform velocity because of velocity of A relative to B. B is at rest, come and collide with the A. Therefore the observe the B comes uniform velocity like this. Okay, this is the graph. Full answer is the full answer for the both of that. So after drawing this, they ask show that the time taken to the collision between the balls. So between the ball, what the time, everything asking from the initial point, right? From the initial point U over G, after that only B is projected. If I mark this is capital T time, so what the idea to find the capital T, and later from here you can add it. So what the time taken to collide A and B by using the second occasion, relative velocity VT graph, right? So what the idea here, velocity of A, like the earlier question, the ring problem impact, question number 1, the same idea here. B is rest, A comes and collide with the A. Therefore, somewhere here at the top you think like that, yes, the B is rest, so A collide with the B. So distance are equal, what they travel, how they travel, this distance equal to this distance, okay. This triangle area equal to this rectangle area, because what the distance traveled by A is the same point, B comes and collide with A. Therefore velocity of the A relative to B, B is rest. So what this answer, same area here, right? So you can show here triangle area equal to the rectangle area. But if I mark some letters here, if I say this is P, here Q, R, S, I say U because of T available there. So in this case, area triangle OPQ equal area rectangle QRSU. So equate the area, half into base into height, triangle area, half into base into height, rectangle area, length into breadth, okay. So both occasion cut this U over G cancel, U over G cancel. They have a capital T equal what? 1 U available here. Capital T what? 1 over 8. Is it okay? 1 over 8 U. Capital T equal. There's a G also. Is it okay? Half into base into height. Half U over G into U. Here 4U over G into that. So find the capital T answer. 4U over 4U over 3. So check properly, check this. I mistake 3 there, therefore U cancel. So 1U available, U over 8, but 3U over 8. This is the time taken after this first throwing, after the first throwing, time taken to the second particle to collide. But the answer is from the initial point. Therefore total time taken at the both U over G plus 3U 3u over 8, first occasion u over g, 3u over 8, okay, is that u over g plus 3u over 8g. Let's take a g, 3u over 8g. So at the board you get the answer, but they given that is 11u over 8g. That's the problem. Question number 2, right? See problem number 3. That is projectile. I hope you complete this everything. Only successful when I explaining this, you can get a good opportunity to by using your answers. Second question, projectile motion. There's a wall, particle is projected, as dust passes that wall. Then they ask the height of the wall, answer is provided there. So use the diagram form, mark everything, use the popular proper formula for that occasion. A particle is projected from a point on horizontal ground by making an angle 60 degrees with horizon. The particle just clears the top of the wall, which is a distance from O. So we mark that. Something like that. This is, I see the wall. Initially O, the velocity, if I say U, 60 degrees angled with the horizon. I say time is t, 0 here. So usual XY plan we are showing this. Okay, so on horizontal ground 60 degrees, the particle clears the top of the wall, which is a distance from O. This is a distance. Okay, a distance. And if the particle reaches the ground at a distance from the wall, this is also given here, this distance what? A by 2 root 3 minus 1, okay? A by 2 root 3 minus 1. Show the height of, if I mark the height is h. Height is h. Show the height is the answer. So, therefore you know the complete horizontal range. Horizontal range is known. So find here, I mentioned the u is unknown part, therefore I won't find the u, and you know the problem involving time factor. So try to complete the time and get the answer. So if I mark a point here P, and if I say Q, and first I complete the full motion to find the time. If I say time is t here, time is t, capital letter T when the particle hit the ground, right? So what the popular formula for this projectile motion? S equal ut plus half ft square. So apply S equal ut plus half ft square. So first I apply vertically upwards, okay, or horizontally you apply whatever you apply this formula. So if I apply from full motion, I say O to Q, right? From O to Q, I apply horizontally apply what the horizontal displacement A plus this, right? A plus A by 2 root 3 minus 1 equal to initial velocity horizontally u cos 60 into, I say, capital T. There's no horizontal acceleration in that projectile motion. This is our first equation, okay? I say first equation, and next apply vertically upward. You can find the capital T from that. But the vertical upward particle hit the ground. I apply from O to Q, therefore no vertical heights, displacement 0. U sine 60 into capital T minus half gt square There, what is the time here? Capital T equal 2u sine 60 over g, okay, 2u sine 60 over g, or otherwise capital T equal 2u over g, what is sine 60, root 3 by 2, okay, root 3 by 2, so 2 cancel, u root 3u over g, right? The time taken to collide this ground after this time by horizontal range also given. Now we got the first equation. You know the t answer, and you can find the small u part, but u is unknown, right? So go to first equation and simplify. Can I take this simplification out there? Take a 2 out. Here 2 plus root 3 minus 1, is it, into a equal u cos 60 half, capital T is what, root 3u, okay, over g. So in this case you can find the u square answer. What is u square is, see, 2 cancel, okay, here what, root 3 plus 1, okay, root 3 plus 1 over root 3 into g, right? This is the velocity. Initially it's square, velocity it's square is the root 3 plus 1 over 3, and there's a here, check value ag, right? Okay, now the question is find the height of the wall. Now we take the motion from O to P. If I take time taken is t, small t here, time is t, so we can find the time t, use the same formula from here to here. You know the a, there's the height, you know u now, you know 60. If you know the time is t value, similar fashion you can find. So next I apply s equal ut, that half ft square formula. Apply s equal ut plus half ft square, where from the words are important for your revision for O to P, right? From O to P, apply from O to P, I apply what, vertically upwards. From O to P, apply vertically upwards. The height is h, okay, height is h, u cos 60, then u sin 60 into t minus half gt square, famous equation. This always happens in this projected problem. This is my second equation, right? Second equation. Next apply horizontally. Next apply this formula horizontally. What is that? A equal u cos 60, okay, into t, right? Into t. There's no acceleration horizontally. So what is that? A equal cos 60 is half, therefore half u t. So you know the t answer is 2a over u. Okay, t answered that simplified form. Okay, u cos theta into t. Cos theta is half, right? So u half ut, therefore t is what, 2a over u. So we applying the second equation for t, also your initial u value can go to the answer, right? So applying the second equation, h equal u sin 60 root 3 by 2 into t, 2a over u, okay, minus half gt square. Square of the t is what? 4a square, okay, 4a square over u square. So simplify, see here, U cancel, 2 cancel, root 3a minus here what? Cut the 2g a square over u square. I say a square. What is 1 over u square? You know the u answer already? Or you can take, yes, what is u square? 1 over u square. Then root 3 up and over root 3 plus 1 into ag, okay? Therefore, the height of the wall, simplify further. Then what happened? 1a cancel, root 3a minus here g cancel, okay? Root 3a 2 times over root 3 plus 1. Now simplify, taking the common thing and using the LCM, simplify root 3 plus 1. And here what? Take the a out, root 3a out, root 3a out. So we multiple root 3 plus 1 minus 2. So check the answer is given there. Root 3 into what? Root 3 minus 1 over root 3 plus 1 into a is the height of the wall, right? Well balanced question for a structure paper. Okay, see my next question 4, problem 4. It's a vector question, simple problem. There is go through and mark the diagram. I hope you complete those things. So mark the diagram and complete. There is, they are given in a triangle ABC. Position vectors of the vertices A, comma B and C are provided. By a diagram form. A, B, C, right? A, B, C. The position vector of the A is 2i plus 4j. 2i plus 4j. So reference to origin, they provide these things. And the B is minus I plus j, minus vector I plus j, minus I plus j, minus j, is it? Minus I minus j, and the vector C is 7i plus 2j. 7 vector I plus 2 vector j, right? So first part question, find the length of the AB, BC, CA. What do you mean length of a vector? Means magnitude, modulus. That means ij component square root of what? X square plus y square. So if you know the BC vector as a vector form, then you can find the magnitude or the modulus length of the line segment. Therefore we find that first you find the vector AB. If you know the vector AB, then only you can find the BC. So what is vector AB? Vector addition. AB vector. Vector AB equal to what? Vector AB equal to what? AC plus CB, that. So first we find the AB. Particular for with the origin, reference to origin. It can be shown as a B minus A, I think, right? Somewhere if I mention somewhere O here, the O is somewhere here. Some other students something confused. They don't learn it properly. This vector, how to find this AB vector. That's why I show with the final chance to those preparing for the exam how to find the particular length in this type of question. Somewhere the origin available. So if you complete the triangle OAB, then you can write the AB vector equal to what? AB vector equal to, so BO minus that BOB, right? BO minus, okay, BO plus OA. AB vector equal to what? PO sum AB vector equal AO plus OB, right? AO plus OB. If I mention O is in origin, right? AB vector equal to AO plus OB. So what the answer? AO is given, OA is given, AO minus times 2I plus 4J plus OB vector is this, OB minus I minus J. Okay, therefore your AB vector simplify minus 2I minus I minus 3I minus 4J minus J minus 5J. If you're very clear how to write the AB means B minus A, XY means Y minus X in the position vector form, right? So if you know the AB vector, how its magnitude? Square root. Therefore AB vector modulus square root of 9 plus 25, okay, that is 34, square root 34 vector AB. Similar part you can find the other vectors, its magnitude. What is BC? I won't show once again same method, so straight I try to work. How to find the BC? C minus B. BC is C minus B. 7I plus 2J minus I minus J. Okay, therefore 7I plus I, 8I, 2J plus J, 3J, is it? Therefore vector BC is modulus length of the BC square root of 64 plus 9, okay, 73. So in this problem, give some ideas on your something a different, a big value to show there. You take some opportunity how to calculate such a problem. The ideas here I am showing how to work in the IJ component, how to find the length of a segment or size of this triangle, that length of the sides. Next we find the AC. What is AC? Magnitude of vector AC is what? C minus A, right? So C means 7I plus 2J minus I. What is the I? AC, C minus A. What is A? 2I plus 4J. Therefore the answer what? 5I minus 2J. Okay, therefore its magnitude AC, length of the AC is square root of, here 25, here 4, is it 29? Check with you. So the values of each. So now the problem is find the length of, okay, by finding the cos A, cos B, cos C. So now you know this length. What is AB length? Length of the AB. Length of the AB equals square root 34. Length of the BC equals square root 73. Length of the AC equals square root 29. Now they ask find the each angle, cos angle, later convert to the sine part, right? Okay, so what I do when the cos comes in vector problems, dot product or scalar product. If you product these two with this angle AB dot AC, mod AB, mod AC, cos theta, cos A. You know mod of AB is root 34, mod of this is root 29, and cos A, you will find the cos A. That's one method. Similar cos B, take these two scalar product. Or otherwise apply the cos rule. That also clear now. Apply the cos rule. So if I say that in triangle in triangle ABC. What is cos A? Cos rule, apply the cos rule. Cos A equal, so I explained two methods, right? One is triangle vector format using dot product within two line known, angle is known. We can use the dot product method. Otherwise, use the cos rule, right? I apply the cos rule. What is cos rule means? Here this square plus this square minus this square over twice of that, right? So that is square root 34 square, square root 29 square, okay, minus square root 73 square over 2 times square root 34 and square root 29, okay. So if you simplify, these answers come 34 plus 29 plus that 74 minus to be subtracted. If you work this answer, you write the value minus 4 over the 2 times that, right? So 2 also cancel. If you simplify, 2 cancel there. Square root of 34 and 29. Okay, this is the cos A. If you work, check this the idea. Next, cos B. What is cos B equal? Apply the cos rule. What is cos B here? Square of this plus square of that, opposite square, subtract. So that means 73 plus 34 minus 29 over 2 times the adjacent product, 73 root and 34 square root, right? So if you simplify like earlier case, you have answer for the cos B. It becomes 39, check value 39 over this 73 and 34 square root, right? Square root 73 into 34. Similar, what is cos C? If you work the cos C on the same fashion, it becomes 34, check value, I have answer, right? 34 over product of the two signs, 73 root of the cos C, 73 and 29, okay? This is the method for first part. Next you change their, show that sine square A plus sine square B plus sine square C answer. So how, if you know the cos, you can go to the sine. So if I write therefore sine square A plus sine square B, the big value but not answers, not a problem, the ideas are the important, right? Sine square C, okay, convert to cos, you know, sine square plus cos square is 1. They have a sine square A, 1 minus cos square A, sine square B, 1 minus cos square B, 1 minus cos square C, okay. So 1, 1, 1, 3 minus, take a minus out. What is cos square? You know the cos A, you know the cos A square root. It becomes 5 square or 25, okay. 5 square over 34 into 29 plus, you know, cos B square root. So 39 square over 73 into 34 plus, you know, the cos C square root, 34 square over 73 into 29. It's a big value, the answer not a problem, right? Don't think about the answer. To simplify, you can go to this value. So if you collect it, you can get that answer, right? It's the question 5. The small part of the vector idea, how to find the length of a line segment, and how to use the cos rule or dot product, and how to use the sine term to cos in terms of cos, and collecting the answer, okay?